Hello, ladies and gentlemen. This is Mrs. Taylor, and I'll be doing the video for our blended learning day for geometry. And so what you'll need to get started for this is your guided note sheets, a calculator, and a pencil. Now, hopefully Mr. Lozar and I remembered to give you our guided note sheet and you remembered to bring them home, but if either one of those was not the case, you can head over to Blackboard and there will be a spot for you to download and print off the guided note sheet. Now, what you need to know about our expectations for this blended learning day is we're going to expect you to watch this video and take notes just as you would if we were in class. Your guided note sheet is going to be graded like a homework grade. So the next time we see you, Monday and Tuesday of next week, you're going to show us that you did your guided notes and you're going to get a homework grade for that. After watching this video, you're going to go over to Blackboard and take a quiz, and that will go in as an achievement grade. So we're going to pay really close attention and give it our best. So let's get started. We're going to do some warm-up problems that are directly related to the skills that we need to have to be able to do our work today. So the first one we're going to do is solve for x. So I don't know about you guys, but I don't know what 65 squared is off the top of my head. I've plugged it into my calculator. I get 65 times 65 gives me 4,225. So 4,225 equals, and I'm going to distribute the 25 into the set of parentheses. And I'm not going to leave anything up to chance. I'm going to go back to my calculator and type in 25 times 25, which gives me 625. So 625. And then 25 times x is 25x. I've got myself a first week of algebra problem. I'm going to subtract 625 from both sides. So 25x equals, all right, well, 4,225 minus 625 gives me 3,600. 3,600, I need to divide both sides by 25. Off the top of my head, I don't know what that is either, so I'm going to go back to my calculator. I'm going to hit divide. It'll put in the answer for me. Hit divide by 25 and enter. My answer is x equals 144. So that is the correct answer for that one. Now, number two, we need to dust off our reducing radicals skills. So I need to look at this. And normally, my class knows that I teach that we should take roughly half of whatever the number and start testing our perfect squares. But honestly, this is much larger than anything that we've dealt with prior to today. So I'm going to just start seeing what I can tell. Now, one of the things that I value about my math skills is looking at numbers and seeing patterns in them. And one of the things that I know is any number that's divisible by 3, well, the sum of each digit is going to be divisible by 3. So what I mean by that is if I take 1 plus 0 plus 5 plus 3, well, 3 and 5 is 8 plus 1. So those digits add up to 9. Because 9 is divisible by 3, I know that 1,053 is divisible by 3. So I'm going to use that knowledge. I'm going to know that this is 3 times something. Well, let's see what I can do. I get 3, 5, 1. So, all right, and I look at that, and I'm going to do the same thing. I'm going to add up my digits. Is 3 plus 5 plus 1, is that divisible by 3? Well, that also adds up to 9. So I can look at this and say, all right, well, then this also works. I'm not doing that one in my head. 351 divided by 3 gives me 117. All right, so my next question is 1 plus 1 plus 7. Is that divisible by 3? Well, it's also 9. So I know that that one is divisible by 3 as well. So I look at that and I say, all right, well, this is 3 times 39. All right, and lastly, is 39, is that divisible by 3? Well, 3 plus 9 is 12. 12 is divisible by 3, so I get 3 times 13. So I get 3 to the 1, 2, 3, I have 4 3's. So 3 to the 4th power times 13. All right. So I look at that and I'm going to use my trusty math skills. I'm actually going to look at this and say, well, 3 to the 4th, that's the same as 3 squared times 13. All right, that's 9 times 9 times 13. And anytime I have 2, I can circle them. 1 breaks out, so I have 9 times the square root of 13. All right. We're actually going to have to know how to reduce radicals. And so hopefully this is an Algebra 1 skill that you remember how to do. If not, you're going to have to figure it out. It's part of the multiple choice part that we're going to do on Blackboard. And I'll give you a strategy for that later on. Let's get started with the actual lesson. So we're going to jump ahead to chapter 8.1, and we're going to talk about similarity in right triangles. But here's the thing, we've already been talking this week about similarity in triangles in general. We're going to talk about special triangles, right triangles, and how they have some special things that happen to them. So we're going to apply similarity relationships in right triangles to solve problems, and then we're going to use geometric mean to find segment lengths in right triangles. All right, so the first thing that we need to get into your notes is this theorem 8.1.1. It says the altitude to the hypotenuse of a right triangle forms 2 triangles that are similar to each other and to the original triangle. Now I'm going to pause for a minute. I want you to pause the video and write that into your notes. Okay, so if you need to, I would back up a little, hit pause, write it down, but I'm going to forge ahead. So what does this say? It says the altitude to the hypotenuse of a right triangle. So it says, I've got some right triangle. Here's my right triangle. And I know it's right because I'm telling you it's right. And it says the altitude to the hypotenuse. What's an altitude, folks? We learned this in chapter 5. We loved it, right? So an altitude goes from a vertex and it hits the opposite side at a right angle. So that's what the altitude is. So this right here, oh, I meant to do that in blue. Let's try it again. So this blue line right here, that's my altitude. And so now I have 3 similar triangles. I have my big triangle, which is ABC. So triangle ABC. All right, I have that triangle. And
Mrs. Denny, please call extension 1100. Miss Denny, 1100.
let's label this one more time. All right, so I have the original big triangle, and now I'm going to talk about the 2 triangles that it's similar. Well, angle A is, it's my hypotenuse and my long leg of my big triangle. So I'm going to go over here and I'm going to find the hypotenuse and the long leg of this triangle. So my hypotenuse is BC right here, and my long leg is this over here, CD. So C and A are my congruent angles. I went to B. B for my big triangle was not the right angle. So if I started with C right here and I go to not my right angle, I'm going to angle B. And then angle C for my whole big triangle was the right angle. So now I'm going to end on the right angle. Okay, so that's that. Let's clear some stuff up so that we can talk about the other triangle. All right. And then lastly, we're going to talk about this triangle right here, ACD. So I need to figure out how to get my similarity statement so that it works with everything else. So, all right, again, I started with A, which was my hypotenuse and long leg. So as I look at this triangle right here, I'm going to my hypotenuse and my long leg. Well, my hypotenuse and long leg is angle A again. So I'm going to talk about triangle A. And then I went to my angle that wasn't my right angle. The angle that wasn't my right angle for this triangle right here is C, right? This is not a right angle. So AC, and then I landed on my right angle. And this angle D is my right angle. So those are my similarity statements for that one. All right, so we need to do the same thing for this triangle. I need to write a similarity statement for these two triangles. So I'm going to talk about the big triangle, triangle UVW. Well, I want to do this consistently for every single triangle. And honestly, I would like to do where I start at the right angle, I go down the short leg, and then across the hypotenuse. So I'm going to start at my right angle, go down my short leg, and then across my hypotenuse. And if I do the same thing every time, things will be consistent, they'll be more accurate, and it'll honestly be faster for me. So I'm going to talk about the big triangle. So the big triangle is, well, I'm starting with my right angle, so angle W. I go down the short side to angle V, and then I stop at the other side of the hypotenuse, which is U. And I say that that triangle is similar to, and now I'm going to talk about this triangle right here. I'm going to do the small triangle. So once again, I want to start at my right angle, go across my short side, and then across my hypotenuse. So I'm going to say that WVU is similar to triangle Z across my short side to V, and then across my hypotenuse to angle W. Okay, so now I've talked about the small triangle, and now I'm going to talk about the other big angle or the other big triangle that's in there. So I'm going to say that triangle WVU is similar to triangle ZVW, and that is similar to triangle. I'm going to start at my right angle, which is right here at Z. So Z, I'm going to go across my short side, which is to W, and then across my hypotenuse, which is U. So now I have my similarity statement. Triangle WVU is similar to triangle ZVW is similar to triangle ZWU. All right, now I need to sketch the three right triangles with the angles of the triangles in corresponding positions. Okay, so I look at this triangle and I kind of feel like it's upside down, but since it's already started that way, that's how I'm going to continue. So my original triangle, my big triangle, looks like this. I've got a right angle down here, and that's W. I come up to V, and this is U. So that's my first. And then I'm going to do triangle Z, V, W, and that's my smallest triangle. So I actually need to, because my directions say sketch the three right triangles with the angles of the triangles in corresponding positions, I need to do it the same kind of way. So I'm going to do my smallest triangle with my hypotenuse facing up. It's like a dead possum. So I'm going to have my hypotenuse. So this is my right angle. So this is Z. And then I have W and V. So that's my smallest of the two triangles. And then I have my medium-sized triangle. Once again, I'm going to put my hypotenuse at the top, my right angle at the bottom. My right angle for this one is Z. I go across my short leg to W, and this is U. So that's how we're going to draw my my medium-sized triangle is much too similar to my original size triangle. Watch this. We're going to do some smartboard magic, and we're just going to make that a little bit more medium-sized. There we go. So we need to write some similarity statements comparing the three right triangles in each diagram. I'm going to barrel through this. Honestly, I think that it would be a good idea for you to watch the first one, pause me, and then come back and check your answers. So I'm going to look at my big triangle, and once again, I'm going to start at my right angle. I'm going to go across my short side, and then I'm going to go across my hypotenuse. So for my biggest angle for number one, I'm looking at triangle L across my short side, which is to J, and my hypotenuse, which is to K. That is similar to triangle. I'm going to go to my smallest one. So I'm looking at angle M is my right angle. So I say triangle M across my short leg, which is to J, and then across my hypotenuse, which takes me to L. And that is similar to, now I'm going to look at my medium-sized triangle, and I'm going to start at my right angle. My right angle is still at M. I'm going to go across the short leg to L, and then across the hypotenuse to K. So I can do this relatively quickly if I remember to use the same setup. So if I always do the same thing, I'll be in a good place. All right, number two. Once again, I'm going to look at the big triangle. I'm going to start at my right angle, and this is harder, sort of. So the thing that's special on this one is I've got angle E and angle F are congruent. That means that this is an isosceles triangle, right? So when I talk about going across the short side and the hypotenuse, well, there is no short side. So whatever I do, I just have to be consistent. So I'm going to start at my right angle, and I'm going to go down a leg. So that's what I need to commit to. So on my big triangle, I'm going to start at my right angle, and I'm going to go down this leg to E, and then across my hypotenuse to F. And I'm going to say that that triangle is similar to, and I'm going to go over to the triangle on the left. I'm going to start at my right angle, which is at G. I'm going to go down one leg. So I'm going to go this way, and I'm going to say G, E, and then my hypotenuse. EF is my hypotenuse for my big triangle. ED is the hypotenuse for this left-hand small triangle. I'm going to say that triangle GED is similar to, now I need to talk about the triangle on the right-hand side. So I'm going to start at my right angle, which is G. I'm going to go across one of the legs to F, and then across the hypotenuse to D. FD is the hypotenuse for this one. ED is the hypotenuse for the other one. And then EF is the hypotenuse for the big one. So those are my three similarity statements for number two. All right, number three is much similar to one. We don't have to worry about the fact that it's an isosceles. So I'm going to start with my big triangle at the right hand, or excuse me, the right angle. So W across the short leg to X and across the hypotenuse to Y is similar to, all right, I'm going to go for my smallest triangle. I'm going to start at angle Z. That's my right angle. I'm going to go across the short leg to X and then down the hypotenuse to W. So that takes care of my small triangle. That's similar to my bigger triangle. All right, so I'm going to start at the right angle. My right angle is at Z. I go down the short leg to W and across the hypotenuse to Y. So that's the similarity statement for number three. All right, so the next thing that you need to get into your notes is the definition of geometric mean. The geometric mean of two numbers is the positive square root of their product. Go ahead and pause, write that down, and hit play when you're ready to move on. Okay, so we have examples 2 and 3. Find the geometric mean of the pair of numbers. Give the answer in the simplest radical form. So the geometric mean of two numbers is the positive square root of their product. What does product mean? Product means that you're going to multiply. So we're going to take 4 times 25. That's going to give us 100. We need to take the positive square root of this number. So the square root of 100, well, that's 10. All right. So I'm going to say 5 times 30. Well, here's where number sense comes into play. So if I look at this, I can multiply 5 times 30 and I can easily get to 150. Or I can look at this and say, well, 30 is 5 times 6. And I know I have to take the square root of this number. So I'm going to look at this and say 5 squared times 6. And then when I take the square root of this, what's the square root of 5 squared? Well, that's 5. Do we know the square root of 6? That can't be simplified. So my geometric mean of 5 and 30 is going to be 5 times the square root of 6. Now, if you don't like that, that's fine. You can do, I'm going to change colors and do an alternate version. I can do 5 times 30, and I can easily recognize that that's 150. Hopefully, you can look at 150 and go, hey, I know that 25 goes into that. And then you can say 25 times 6, and when you take the square root of that, you can easily say that the square root of 25 is 5, and that 6 can't be simplified. You can get to the same place taking either root. All right, so let's try finding the geometric mean. I want you to follow along while I do number 4. Then I would love for you to pause, work it on your own, and then come back. So the geometric mean is the positive square root of the product of these two numbers. So 1/4 times 4. 1/4 times 4. Well, don't these things cancel out? Wouldn't I have the square root of 1? Yes. What's the square root of 1? It's 1. All right. Go ahead and pause. Give it just a second. Get your stuff done and then come back and take a look at what I've got. All right, I'm going to do the positive square root of the product of 3 and 75. Well, I look at 75 and I say 75 is 3 times 25. Can I take the square root of 3 times 3? I can. The square root of 3 times 3 is 3. Can I take the square root of 25? I can. The square root of 25 is 5. So the answer to this one is 15. Now you can go to your calculator, you can plug in 3 times 75, get 225, and hit the square root button. But when we're talking about simplifying square roots, we need to remember that this calculator isn't going to give us the simplest radical form. All right, I'm going to look at number 6. It's going to be the positive square root of 4 times 18. Well, 4 is already a perfect square. So I can take the square root of 4 and say that's 2. And then I can look at 18 and I can think about what perfect square might go into 18. Well, the biggest perfect square that goes into 18 is 9. So 18 is 9 times 2. What's the square root of 9? Well, that's 3. So I'm going to say 2 times 3 times the square root of 2 because I can't do anything with that. 2 times 3 is 6. And the square root of 2 is as simplified as that gets. So that's going to be my final answer for that one. All right. I'm going to race through these. You can take a minute and pause if you want and come back. Well, this is a yucky one. I don't know what the square root of 1/2 is, but I know that the square root of 9 is 3. So I'm going to say 3 times the square root of 1/2. And honestly, that's not how we would typically write that. We would say 3, the square root of 1 over the square root of 2. The square root of 1 is just 1. And we talked about this a couple of weeks ago. We're not allowed to have square root in the denominator. So the way I get rid of it is I'm going to multiply by 1 in the form of the square root of 2 over the square root of 2. And the reason why I do that is the square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is just 2. So that's what's on my bottom, and I'm allowed to have the square root of 2 in the top. So this is my final answer for this. And again, I'm going to give you a strategy. If you have difficulty with this, you really do need to get better at it, but I'm going to give you a strategy to help with the blended learning quiz on Blackboard. All right, the square root of 10 times 40. Well, I recognize that 10 is 5 times 2, and I recognize that 14 is 2 times 7. Well, I've got 2 and 2 in the middle, so I'm going to say those two group up, and I can put 1, 2 on the outside. 5 is as simple as I get, and 7 is as simple as I get. There's no perfect square that divides into either one of them, and there's no perfect square that divides into their product. So my final answer for this one is 2 times the square root of 35. All right, and this one says 4 times, or 4 and 12.25, so I'm going to take the positive square root of their product, so 4 times 12.25. All right, so I'm going to run over to my calculator and see what it says. I'm going to punch in 4 times 12.25, hit enter. 49, that's good news, because I know that 49 is a perfect square, and the square root of 49 is 7. So that's my final answer for that one. All right, so just a reminder how the proportions are set up. We need to talk about the similarity. So if I list my large triangle and I start with, I'm going to do the same thing that I did before. I'm going to start with my right angle. I'm going to go across my short leg, and then I'm going to go across my hypotenuse. So I'm going to do triangle CBA. I'm going to call this middle triangle, I'm going to call it triangle DCA. So I started at my right angle, I went across my short leg and across my hypotenuse. And then for my small triangle, I'm going to say triangle D across my short leg to B, and then across my hypotenuse to C. And this is where we need to set up those similarity ratios. All right. So let's see, I can say that CB, my first two, over DC, my first two and the second one, equals okay, sorry about that. I want to try something different. So I started down the wrong path and I realized this isn't how I wanted to talk about this. I want to talk about the proportions of the hypotenuse over the short leg. All right, so the hypotenuse for the big triangle, well, that's C, right? The whole length of that side is C. And then the short side for the triangle on the far left is A. And that's going to equal, when we look at the middle triangle, that's going to equal the hypotenuse of that over the short leg for that, which is labeled as H. And then I'm going to come over to the smallest triangle all the way on the far right, and I'm going to put the hypotenuse of that over the short leg. So I have those proportions that I can talk about. I can talk about the hypotenuse over the long leg. So the hypotenuse for the largest triangle is C, and the long leg for the largest triangle is B. In the middle triangle, I can talk about the hypotenuse B over the long leg, which is Y. And for the smallest triangle, I can talk about the hypotenuse, which is A, over the long leg, which is H. Now remember, we've got this one main triangle. I drop an altitude, and I end up with a bigger triangle and a smaller triangle that result from that. So this is where all these letters are coming from. And lastly, I can talk about the ratio of the long leg over the short. So for the biggest original triangle, I can talk about the long leg over the short as B over A. And that proportion is going to equal the same ratio for the middle triangle. The long leg is Y and the short leg is H. And that proportion equals the long over the short for the smallest triangle. And that's H over X. If you need to, take a pause and get that put down and then come back. All right, the next thing that we're going to put into our notes is corollary 812. And it says, the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the two segments of the hypotenuse. So what does that mean? All right, so I have this original right triangle, and I put in an altitude. The altitude hits the other side at a right angle. And I have these two segments, X and Y, and my altitude is H long. And so this corollary says that the altitude, the length of the altitude, is the geometric mean of the two segments of the right triangle. So what that ends up being is it says that the length of the the length of that altitude is the geometric mean of the two segments of the hypotenuse. But this is kind of ugly. But if I square both sides, I end up with something that's a little bit easier to work with. So that's what this means. That's how we're getting this statement right here. All right, the next thing that we need to get into our notes is corollary 813. The length of the leg of a right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse adjacent to that leg. All right, so what that means is I have my right triangle, and I have my altitude that comes in at a right angle, and I have X and Y. And it says that A is the geometric mean. The geometric mean is the positive square root of the product of two numbers. It says it's the geometric mean of the length of the hypotenuse. Well, the hypotenuse, the whole hypotenuse, we have labeled as C. So it's the length of the hypotenuse times the side adjacent to that leg. Well, here's my leg, and X is the side that's adjacent. Well, this is also an ugly statement, so I'm going to square both sides, and that's going to give me a squared equals cx. So these are the things that we're going to remember. All right, and then I'm going to talk about same triangle. I'm going to talk about got my altitude h, which breaks my hypotenuse into x and y. My entire hypotenuse is c units long, and this side is b. So b is the geometric mean of, So positive square root of the entire hypotenuse, and then the segment that's adjacent to side B. Well, this is side B, so the part that's adjacent to side B is y. That's ugly, so I'm going to square both sides, and that's going to give me b squared equals cy. So that's where these formulas come from. That's what I really want you to get down. The corollary 812 and 813, and then these two formulas that are boxed up in blue. All right, now we're going to put this to use. So I need to find x, y, and z. Well, when I look at this, I don't want you guys to forget about the Pythagorean theorem. The Pythagorean theorem says a squared plus b squared equals c squared, and I can only use it on right triangles. Well, when I first look at this, I go, well, I've got a right triangle that I can apply that to. And that right triangle is right here. My hypotenuse is z, and 9 can be a, and 6 can be b. Well, 9 squared is 81, and 6 squared is 36. All right. Well, in that warm-up, we ended up having 117 as one of our numbers. And I remembered that 117 is divisible by 3 twice. So I'm going to come over to my calculator and say, all right, 117 divided by 9 gives me 13. Whoops, this should be squared. So z squared equals 39 times 9. I'm going to take the square root of both sides. So the square root of z squared is z. The square root of 9 is 3. And I can't get a perfect square to divide into 39. So my final answer is going to be 3 times the square root of 39. So that tells me what z is. All right. Now I need to figure out what x and y are. So over here, I'm going to erase all this junk. Over here we had x squared was the altitude equals xy. This is the one that we're going to use. So I'm going to come over here and I'm going to say the altitude squared equals the two segments of the hypotenuse. So 9 times x. Well, the altitude is 6, so I'm going to fill that in. 6 squared equals 9 times x. 6 squared is 36. 36 equals 9x. I'm going to divide both sides by 9. And that's going to give me x equals 4. Okay, so x equals 4. The next thing I need to do is figure out y. I can do y one of two ways. I can come over here and I can use a squared equals x times c, or I can use the Pythagorean theorem. I'm going to use this. I'm going to use a squared equals x times c. So it said a squared equals x times c. Well, a squared was the short leg. So the short side squared equals x. X was the part that was adjacent. And as it turns out, x is x for my example. So that's 4. And then c is the entire length of the hypotenuse. Well, now I know that the entire length of the hypotenuse is 9 plus 4, and 9 plus 4 is 13. So my short side, which is y squared, equals 4 times 13. I'm not even going to multiply that out because I just need to turn around and take the square root of both sides anyway. The square root of y squared is y. The square root of 4 is 2, and I can't do anything with 13. So it stays under the radical sign. So y equals 2 times the square root of 13. So for my example, x equals 4, y equals 2 times the square root of 13, and z equals 3 times the square root of 39. All right, we got to throw a word problem in there. It's not a good blended learning day without a word problem. It says to estimate the height of a Douglas fir, Sven positions himself so that his line of sight to the top and bottom of the tree forms a 90-degree angle. So this angle right here is 90 degrees. All right, his eyes are about 6 meters, or excuse me, 1.6 meters above the ground. So that's labeled over here. And he is standing 7.8 meters from the tree. So, all right, I look at this and I go, I've got this triangle right here. It's a right triangle. This is 1.6 and this is 7.8. I'm going to use the Pythagorean theorem and I'm going to say c squared equals 1.6 squared plus 7.8 squared. And I am not doing that in my head. So I'm going to come over to my calculator and I'm going to say 1.6 squared gives me 2.56. 2.56. And then I'm going to go back to my calculator and I'm going to put in 7.8 squared. And that gives me 60.84. 60.84. And I'm going to add those two numbers together. So I'm going to just hit answer, and that's going to give me my 60.84 to load that in there, and I'm going to hit plus 2.56, and that's going to give me 63.4. 63.4, but I need c, not c squared. So this is not a problem that we're going to do in simplest radical form. It actually tells us to round to the nearest meter. So I'm going to take the square root of 63.4. And on this calculator, I can hit control and this little minus sign down there. Above that, it says answer. So I'm going to hit control, answer, and enter, and it gives me the square root of 63.4 is 7.96. I look at that and I go, I'm rounding that to 8 right now. So I'm going to say C is, and I'll tell you what, for the sake of just being 100% accurate, I'm going to say C is approximately equal to 8, but that's what we're using. All right, now I'm not after C. So this right here is 8. This side right here is 8. And I had corollary 8.2.3 or 8.1.3, and it said the length of a leg of a right triangle. The length of the leg of the right triangle, which is 8, is the geometric mean. And in this one, we said, all right, well, we have to square that. And it's the geometric mean of the entire hypotenuse. Well, my hypotenuse is this length right here. And I don't know what my entire hypotenuse is. If I call this piece up top x, then my entire hypotenuse is x plus 1.6. So my short leg is the geometric mean of my entire hypotenuse times the little piece of the hypotenuse that's adjacent to it, which is talking about this section right there, which is 1.6. All right, so I'm going to distribute this into my set of parentheses. 8 times 8 is 64. 1.6x. I already calculated that 1.6 squared was 2.56. I need to subtract 2.56 from both sides. All right. I don't know what 64 minus 2.56 is, so I'm going to come back over to my calculator. 64 minus 2.56 gives me 61.44. 61.44. I need to, divide both sides by 1.6, and x equals, all right, back to my calculator. I'm going to divide by 1.6, and that's going to give me 38.4. All right, folks. I don't know about Mr. Lozar, but in my class, I stress that once we find x, we're not finished. We have to go back to the original problem and reread the question. It says, what is the height of the tree to the nearest meter? All right, well, I found x, and x is just this portion right here. So if I need to know the entire height of the tree from here to here, I need to do x plus 1.6. So the height of the tree is going to be 38.4 plus 1.6. So the tree is 40 meters tall. Yay! All right. Pat yourself on the back. That's a lot of work that we just did. All right. So on the handout that you have in front of you, on the very last page, page 3, page 4 is blank, thank goodness. You have 10, 11, 12, 13, 14, 15. So I'm going to do 10 all the way, and I'm going to do 11 all the way. Your Blackboard quiz is to do problems 12, 13, 14, and 15, finding x, y, and z. Then you're going to skip down. You're not going to do the word problem. And then you're going to skip down. I'm going to do problem number 17, and you're going to do problems 18 and 19. Okay? And I'll tell you what, I don't know about Mr. Lozar, but if you show me problem 16 done and correct, I'll give you 5 homework points. Okay? So there's a sweet spot for you. If you do number 16 and show that to me on your piece of paper and you get the correct answer, I'll give you 5 homework points. Okay, so let's do number 10. So I've put the corollary on this page to help us get started. The length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the 2 segments of the hypotenuse. All right, so what does that mean? Well, the altitude goes from the vertex of the big triangle and you come across to the hypotenuse and you hit at a right angle. So my altitude is x squared for this because our formula ended up being x squared equals, and then we took the 2 segments of the hypotenuse that altitude created. So x squared equals 5 times 7. 5 times 7 is 35. The square root of both sides is going to give me x equals, well, guess what? That's as simplified as that gets. X equals the square root of 35. All right, so what else do we need to do? I need to figure out, all right, let's look at y. There's no advantage for this one, whether we start at y or z. So, oh, hey, look at this. I just figured out x. And I don't know about you guys, but I don't mind the Pythagorean theorem. So I can do this. If I look at this triangle right here, and I know that x is the square root of 35, can I figure out y just using the Pythagorean theorem? I can. Y is going to be my hypotenuse. So 5 squared plus the square root of 35 squared equals y squared. All right. 5 times 5 is 25. The square root of 35 squared is 35. 35 and 25 is going to give me 60. And I need to figure out what the square root of 60 is. And I need to do it in simplest radical form for all these answers. So I'm going to come over to 60 and I'm going to talk about, all right, I'm going to take half of 60. Half of 60 is 30. The largest perfect square that's smaller than 60, or excuse me, smaller than 30 is 25. Does 25 divide evenly into 60? No. Does 16 divide evenly into 60? No. Does 9 divide evenly into 60? No. Does 4 divide evenly into 60? And that's where we hit it. So 60 is 4 times 15. I'm going to take the square root of both sides. All right, the square root of y squared is y. The square root of 4 is 2. And I can't simplify 15. There's not another perfect square that goes into that. So that gives me that. All right. Well, I was able to use the Pythagorean theorem for that. And now I can look at my triangle and I can use the Pythagorean theorem again. I mean, I can use that corollary, but why not use what we know? All right, so I need to find z, and again, z is my hypotenuse for the red triangle. So I'm going to say that the square root of 35 squared plus 7 squared gives me z squared. All right, z squared. The square root of 35 squared is 35. The square root, or excuse me, 7 squared is 49. And I end up with z squared equals 84. All right, I need to take the square root of both sides. The square root of z squared is z. And I'm going to look at 84, and I'm going to think about what goes into 84. And honestly, 84 is 4 times 21, and I can't get another perfect square out of 21. So I'm going to say the square root of 4 is 2. I can't simplify the square root of 21. So z equals 2 times the square root of 21. So that's number 10 finished. We've got x, we've got y, and we've got z. Let's take a look at number 11. Okay. So I immediately look at this and say, well, I can use the Pythagorean theorem to figure out what y is, right? So I look at that and I say y squared plus 10 squared. My hypotenuse for that red triangle is 20. So equals 20 squared. Y squared plus 100 equals 400. I'm going to subtract 100 from both sides. Y squared equals 300. I'm going to take the square root of both sides. When I take the square root of both sides, I'm always looking for perfect squares. When I take the square root of both sides, I say, well, the square root of y squared is y, and I can simplify 300 into 100 times 3, and 100 is perfect square. So the square root of 100 is 10. I can't simplify 3, so it's the square root of 3. So y equals that. All right. All right. At this point, I really need to go back to my corollaries and use that to get me what I need to know. So and I put 8.1.3 in here, but I think that this right here is going to be more helpful. So I'm going to copy this and bring it over here. All right, so this tells me that the length of the altitude, and I know the altitude, the length of the altitude, this is the one where we had the altitude squared was the geometric mean was the product of the two segments, the product of the two segments of the hypotenuse. So my altitude for this is y. So y squared is 10 times the square root of 3 squared. And my product of the two segments, well, I look at my hypotenuse, and that's broken into x and 10. So this is 10x. 10 times the square root of 3 squared, well, that's 10 times the square root of 3 times the 10 times the square root of 3. 10 times 10 is 100. The square root of 3 times the square root of 3 is 3. So 10x equals 300. I'm going to divide both sides by 10. So x is 30. All right, so what do I know now? I know x is 30. I know what y is. So if I look at this, I've got another Pythagorean theorem that I can use. So I look at that and I say z is my hypotenuse. So z squared equals, I'm going to come over here and draw that in so that I stay separate. My legs for this are 30. So 30 squared plus y squared. Well, y squared is 300. How did I know that? Well, over here I have y squared equals 300. So rather than go through that whole rigmarole of 10 times the square root of 3 squared, I'm just going to plug that in. 30 squared, is that 900? Let's just double check that. 30 squared, 900. All right, 900 plus 300 equals z squared. Z squared equals 1,200. All right. So I'm going to separate what I know. I need to take the square root of both sides. And I know that the square root of z squared is z. And I'm going to think about 1,200. And I'm going to say 1,200 is 100 times 12. And then a little red flag goes up because 12 is 4 times 3. Well, the square root of 100 is 10. The square root of 4 is 2. And 3 is the only thing that I can't simplify. So that stays as the square root of 3. All right, so 10 times 2 is 20. So z is 20 times the square root of 3. So those are our final answers. Z equals 20 times the square root of 3. I have x, I have y, and I have z. So hopefully you can persevere. You can use the two corollaries. You've got those written down in your notes, and you can use those to solve 12, 13, 14, and 15. So the next thing I'm going to do is I'm going to look at number 17, and 17 is considerably easier. So for these, you can do them a couple of different ways. You can look at the corollaries and figure that out. I'm a big fan of the similar triangles, so I'm really going to come over here and say, I have B and E. So I have this triangle right there, and B is the short side of this red triangle, and E is the short side of this green triangle. So I'm going to say E over B is equal to, well, it wants to know E. E is, all right, what is E in the red triangle? E in the red triangle is the long leg, right? E is the long leg in the red triangle. So I need to find the long leg in the green triangle. The long leg in the green triangle is C, so C over E. So you can set up similarity ratios. That's one way to do this. I can use the corollary. The corollary says that the altitude squared equals the sum of these two numbers. So B times C. So I look at that. If I cross multiply it over here, I would have E squared equals B times box. And I look over here and I say, all right, well, I have E squared, I have B, what goes in the box? Well, this is what goes in the box. So for number 17, the answer is C. So you'll be able to spend just a short period of time to get numbers 18 and 19. So at this point, you're going to head over to Blackboard, you're going to do the quiz. Keep in mind that this has to be finished by Sunday at 4 o'clock. And don't forget that we spring forward, so you lose an hour on Sunday. So get this done on Friday, and you'll be in good shape. Thanks, everybody. Send us an email if you have questions. We appreciate it, and have a great weekend.